Who's ready to do some science?
I am.
I think it's time. So I'm going to ask folks, go ahead and put your computer on speaker view. So you're going to see the Little Shop of Physics team. And we're going to be monitoring the chat as we go. And we have a bunch of science experiments to share with you today. And our hope is you're going to learn a thing or two about heat and thermal energy. And we're going to show you a bunch of stuff that you can try at home, because that's always our goal, is to show you science is something you can do. It's not just about watching us. It's about taking some of the stuff and trying it, with one exception. And here's one we want you to not try. I have this piece of cotton in my hand. It's a special kind of cotton, and you can only get it at a magic store. And if I take that and put it in my hand, touch a match to it, it lights up in this giant ball of flame. And here's the interesting thing, that didn't hurt. My hands are fine. And the reason my hands are fine is because they've been sitting here for a long time and my palms have gotten sweaty, and the heat went into turning the liquid water on my palms into water vapor. And so my hands didn't get warm. What I did is just made a big cloud of steam, but I stayed cool as a cucumber. Was a warm cucumber. And that introduces us to the idea of changing phase. We change some water from a liquid to a gas, and we have some other phase things going on. I'm going to go over to Sheila, my
Hi
partner
there.
in crime right next door.
I have a candle here and a balloon that I blew up with just the air in my body. And I want to see what happens to the balloon when it is held over the candle.
I think I know what's going to happen to a balloon when I put it over a candle. I'm pretty sure, but let's just try it and find out. Balloon plus candle equals pop. Pop
well,
balloon.
That didn't work well, and my candle went out too. So let me see if I can light it again.
All right. But wait, there's more.
There is.
And now, Sheila.
I have a water balloon.
A water balloon? What? Don't put the water balloon over the candle. We know how this is going to end.
I know, I put a big towel out just in case.
Water balloon on top of the candle.
I'm putting it right into the flame.
Right into the, oh my gosh, look at that. That flame is touching the balloon. And what is happening?
Nothing.
Nothing. Crazy.
I have to show you what the bottom looks like. It turns out that the carbon that is being combusted is going away, but the carbon that doesn't quite combust is collecting on the bottom of the balloon.
Oh my gosh, so that's actually from the candle flame. And the balloon didn't pop. And why didn't the balloon pop? What kept it cool?
Well, water has this big heat capacity. And so as I put...
Awesome. And this is something folks could try. This is just a water balloon plus a candle. Ask your folks if you want to try this, but it's kind of amazing. It looks like magic, but it's not magic. This is science. And next, for another phase transition thing, we're over to Brenna, and this is another one with water.
Yeah, so here I have a big bowl, and I don't know what is going to work best, Patrick, for this. Here we go. We'll get you guys a good view. All right, so I have Franklin. We saw him on a previous episode, and I also have this little boat here. And what I'm going to do is I'm going to make a tiny steam engine. So I'm going to take a match. I have a little candle here. I'm going to light the match. I'm going to light my candle. There we go. Put my match out. And then I'm going to put this candle into my little boat. And what it's going to do is it's going to start boiling water in this little chamber up here. Oh, my candle went out. Let's try it again.
And so the energy is going from the flame into the water, and it's turning the liquid water into water vapor.
And for some reason, my candle is just not wanting to light at all.
You can just let the match sit there.
There we go.
Oh, you got it? Okay.
I think I got it. See if we can get it to go. This is a tiny steam engine, so it's going to heat up some water in there. And then hopefully, we'll see, I might have to give it a boost.
And Brenna's putting a little bit of water in the chamber.
Come on, little putt-putt. Oh, there we go.
There it goes, I hear it.
Woo! and the steam will start to push out of the back, and then the boat goes. So this is a little steam engine. There he goes, and it makes a fun little noise.
All right, and somebody says they have that boat. Purva says that. Awesome, awesome. That is a great thing. It's just a little tiny steam engine, and what's inside there? There's just a little piece of copper tubing, and it's just coiled in a circle. And it's like the simplest steam engine I have ever seen. So that was something changing from a liquid water into water vapor, into steam. But we have something else where we're going to turn a solid into a liquid. We're over to Sheila, and Sheila's going to make a special treat.
I am, and I think I'll share. I wish I could share with all of you, but I have a cotton candy machine here, and we're going to use Jolly Ranchers today. It turns out you can crush up 2 Jolly Ranchers, and here I have a hammer, and you can just chop it or pound it up into powder. I put 2 bags there because it does seem to break the bag. And then I have some already that's pounded out here, so I'm going to put 1 scoop in the machine, and I have to turn it off so I'm safe.
And the machine is nice and hot.
It is very hot. I've been heating it up for 5 minutes.
And we put in solid sugar, and it's sugar that's made from crushing Jolly Ranchers.
Oops. Oh, I see some things happening.
Oh my gosh.
Okay. All right, I'm going to turn it back on. And oh, I see that it was melting. Man, it is spinning like crazy.
Oh my gosh.
Oh my gosh.
There's a cloud forming, and it's a cloud.
And now it's turning into a solid again.
So we took that solid sugar, turned it into liquid. The liquid squirts out the holes, and then it turns into basically sugar glass. Turns back into a solid. So she took Jolly Ranchers, melted them, spun them into basically spider silk.
It does look like that, doesn't it?
But you made cotton candy, and it's cotton candy that I think probably tastes like Jolly Ranchers. Give it a taste and tell us what you think.
Face mask. Oh my gosh, it's good. It's cherry. I love cherry.
Cherry Jolly Rancher flavored cotton candy. Awesome. Uh-oh. And somebody mentioned they didn't get their glasses yet. Don't worry, we put the glasses in the mail. They are on your way. Not to worry, not to worry. And next, that was a phase transition from a solid to a liquid and back to a solid. Brenna's got another phase transition for us. What do we got, Brenna?
Yeah, so we're going to do something where we have a liquid and it turns back into a solid, which we also know as freezing. And sodium acetate is cool because at room temperature it's super cold. If I pop this little button here, it starts to freeze. And actually, when things freeze, they release heat. So this gets pretty hot to the touch. And we give these out in Little Shop of Physics to the schools we go to as hand warmers. But we decided in Little Shop that everything we do needs to be big. So I have this big tray here, and I'm just going to gently pour this stuff onto it.
Oh, and so
And there it goes.
Filling up the tray. Oh my gosh. And it started freezing spontaneously. Look at that. It's spontaneously freezing and making little ice patches.
Look at that.
Oh my gosh. Oh my gosh. It's just like the hand warmers. That is awesome.
And if I pick up the tray, it's warm.
Oh my gosh. So, that's amazing.
Yeah. Super cool. And you can melt this and you can do it over and over and over again.
Fantastic. Brenna, thank you for that. And now we're going to go over to Sheila for another phase transition. And this is one with wire, and it's wire that changes not from a liquid to a solid, but it's a different kind of behavior.
It does, and I wanted to show you the shape of this. This is called Nitinol wire, and it's made from nickel and tin. And it turns out that I can stretch it out. So there you can see I've stretched out like that.
We might have to come a little close. There it is. Now I'm seeing it. Awesome. Okay. There's the wire. It's all stretched out.
And now what I'm going to do is add heat to it and see what happens, because this also is called memory wire. So even if you stretch it out, it remembers where it started.
Awesome. And Sheila hits it with the heat. And as the wire gets warm, look, it's changing. It's kind of like flopping around, and it's going back to where it came from. And it remembers its original shape. That is an awesome thing. So it's like changed its behavior when you got it warm. Awesome.
You can try it in hot water too, but we figured you would have a hairdryer at home. That's a little bit safer.
All right. And next we're going to go over to Brenna, who's going to show us another thing that changes behavior. And Brenna has got special ink pens, and they're called Friction, Frixxion. These are one of our favorite things. And Brenna, you've done a piece of artwork there.
I have, and this is my little shop giraffe here. If you guys can see
We're coming
him.
a little closer so we can see it. There it is.
There
Little
we
Shop of Physics
go.
Giraffe. Awesome.
So this ink, these are Friction pens, Frixxion, I believe. And they're pretty neat because when you add heat, the ink disappears. So they have these little erasers, rubber-tipped erasers, and when I rub it, it heats up and it disappears. But you can do this with other things too. So like I have a bouncy ball here, and I'm going to erase this up here, and I'm just creating friction between the paper and the bouncy ball. You can see I completely erased my high up here. But one thing you can also do with this is you can have a hair dryer. I'm going to turn it on high. I'm going to get it real close.
Oh my gosh, you're erasing your giraffe. It's disappearing. Erasing with a hairdryer. What?
Let me see if I can get it to fully disappear.
And Brenna, that's too sad.
And since this disappears with heat, that means you can bring it back to life when you cool it down. So I'm going to give this to Brian. He's going to do some special stuff that we don't want you to try at home.
So camera's going to stay on
Yep.
Brenna.
And I'm going to set up my fan here, and we're going to make it reappear like magic.
So I'm putting a liquid on here. I'm going to hand it back to Brenna. And it's a very cold liquid. It's a very cold liquid.
And I am going to cool it off by running air across it.
And when she does that, oh my goodness.
My ink is reappearing.
So the ink wasn't actually gone. What happens is it just turned transparent, and now we made it come back again. So we had a disappearing and reappearing giraffe.
Science giraffe.
Science giraffe. Awesome, awesome, awesome. You can also make that ink reappear if you put it in the freezer, which is kind of an awesome thing. Now we're going to show another thing that changes when you get it warm. And Sheila's got a container, and this is one that's a recyclable plastic, and we're going to recycle it in a different kind of way. Over to Sheila.
We are. It turns out that when they make their and then they stretch them out into the shape like this. Well, we took a plate like this, put it in this toaster oven for about 2 minutes, and it turned into this. So that's pretty cool. This is number 6, plastic, which is really hard to recycle, but you can recycle and make art. So we have a yogurt container that is size number 6, and also we have some shapes that I used from some trays that are number 6. And I wanted to show you, they really do shrink in the toaster oven because this was the original size. And I should
Wow,
put
it's like
the
quite a
world
bit smaller.
like it is. There it is. On the white? Yes.
All right, look, that got quite a bit smaller. And then
It
Sheila,
did.
show us that container that's a number 1, because that number 1 container, I get stuff like that at the grocery store.
Me too. So I have this container. We cut the bottom out of it, and this is a number 1. It can be recycled in the recycling bin, but why not have some fun and do some art with it? When we put this piece in, this is the bottom of the container, it turned white and the edges curled. Now I want to show you what I got when I did the lids. They didn't shrink quite as much. And that was interesting to us because one is the lid, one is the base, but they're both recyclable number 1.
All right, and so just made some shrinking plastic out of things that you can recycle.
And remember, we love
We
science.
do love science. And that's something we might have to post a recipe for, because that's one that takes a couple of steps. Now we're going to transition and talk about another kind of energy. And our transition is going to be this. I have a camera flash here. And when I hit the camera flash, it gives off a tremendous amount of light. But it also gives out a tremendous amount of thermal radiation because it gets very, very hot. So we're going to do an extreme close-up of the paper here. And I'm going to hit this with the camera flash, and I want you to just watch the area between the camera flash and the paper. And this is just a picture from the Rocky Mountain Collegian. What you get is smoke, and it has actually vaporized the ink. There was so much light and so much thermal radiation that was given off by this hot light bulb that it actually vaporized the ink, and you could see it make that smoke. And this is just a regular camera flash and a copy of the Rocky Mountain Collegian that I got down at the newspaper stand downstairs. And that takes us into thinking about thermal radiation, which is our next segment. I'm gonna do a quick introduction here. Now check this out. I got two light bulbs. This one is a 75-watt light bulb that gives off. This one is a 75-watt light bulb, but it doesn't glow. Or you're thinking it doesn't glow, but in fact it does glow, and it glows with a type of radiation we call thermal radiation. We have a camera that can pick it up. So we're going to switch over to our thermal camera view and see what this looks like, because right now it's giving off 75 watts of radiation, but it's giving off 75 watts of thermal radiation. You can't see it. Reptiles, certain reptiles can see it. Rattlesnakes can see thermal radiation, and here it is. This is my 75-watt light bulb, and it's giving off this thermal radiation, and we can see it on the camera that picks up the thermal radiation. And if I put my hand near it, I can tell it's really warming up my hand. It's making this thermal radiation, and anything that's warm emits thermal radiation. And we're going to show this. We're going to go over to Emma, and we have a new participant here. Emma is over here. And let's look at Emma first in the visible light. And there's Emma. And then Emma has got a piece of foam core. And if she rubs that piece of foam core, there's a bit of friction. We saw with the pens. But now if you look at the thermal camera, you can see she's warming it up. And what she's actually doing is taking those molecules, setting them in motion, making them vibrate, and they're giving off thermal radiation. That is crazy. That is crazy. And so it leaves a little trail behind. Cold finger, so it's not her fingers warming it up. What's warming it up is that friction, just as we saw with the friction pens. And now we're going to go over to Sheila. And let's look at Sheila in the visible light. And Sheila's gone.
Yes, tell us more.
She's got a mask on, and she's holding in front of her face a little glass ball.
Probably not very exciting. You can just see me.
Yeah, and you can see Sheila through the glass. But now if we look at her on the thermal camera, you can't see the thermal radiation through the glass. The glass blocks it. And so Sheila, if you move that thing off to the side, what you'll see is there's Sheila. And she brings it back, and you can't see Sheila through the glass because the thermal radiation won't go through the glass. But there are things that it will go through. And now we're going to go back to Emma. We'll take a look at Emma in the visible light. And Emma is going to hold a balloon in front of her face. And that completely blocks Emma, except now let's take a look at it on the thermal camera. And it turns out, Emma, bringing that balloon back in front of your face, we can see Emma through the balloon. The balloon is transparent in the thermal radiation. It goes right through the balloon. So thermal radiation behaves differently than regular light. Now, one of the reasons this is really important for us, and this is a subject of quite a bit of discussion these days, is that there's certain gases that absorb and emit thermal radiation. And we call these greenhouse gases. And over here, we're going to go over to Sheila. And in the visible light, you can see what Sheila has got. And Sheila has got a little can of sterno, and she's going to move that a little bit closer to her. So we can see, oh, there we go, awesome. And there's a huge flame coming off that.
I can barely see it though.
Huge flame, but she can barely see the flame. But if we look at it in the thermal camera view, let's take a look at it. There it is. And what you're seeing is the thermal radiation from the carbon dioxide and the water vapor that come off the flame. So in visible light, we see nothing, but in the thermal radiation, we see that. And that is actually thermal radiation being emitted by the carbon dioxide and the water vapor in the flame. And now Sheila's got a hot air hairdryer. Let's go ahead and turn that on and let's see what we see out. So regular air when it's hot, what you see is nothing. Nothing at all. Awesome.
We certainly heard it. But
Oh, you could hear it for sure. Let's go back to, oh, Sheila, go ahead.
Not a greenhouse gas, just hot air coming out.
Hot air coming out. No greenhouse gases. We can't see them. And now we're over to Emma. And Emma is warming up her hands for the next piece of the puzzle. Oh, yeah. She's using a heat pack to warm up her hands, which is awesome. And you can actually just take the heat pack and set it there. When you set the heat pack on that piece of foam core, set your hand on the piece of foam core, you're transmitting heat by what we call conduction. And then it's going to warm that up. And we can see, because if you move that heat pack away, it leaves a warm spot behind. And Emma, if you take your hand away, it leaves a warm spot behind. And so there's a trace of you that stays behind, which is kind of an awesome, awesome thing. Now, I'm going to do a quick demonstration of what we're going to do for our last topic. And right here, I've got a little hot plate, and I'm going to turn it on and make it nice and hot. And when that warms up, what's going to happen is this. Air is going to warm around it. And the warm air is actually going to rise. And as the warm air rises, we'll be able to see that. And I took this little thing, and this was my craft project. I took a piece of paper and I just cut it into a spiral. Just took a circle, cut it into a spiral, and attached a lightweight piece of string to the center. And so I made a little spiral like this. And if I bring that little spiral and I put it over top of the hot plate, you can see what happens is it starts to spin. And it's spinning because of the rising air from the hot plate. Let's let that get some good speed here. There it goes, there it goes. I'm doing a little hot air rising, driving my little spiral. And you can do that over anything warm-ish. Works really nicely over this little hot plate. It's also interesting to try it over something cold. Put it next to your fridge, open the door, and watch what it does. And that is an awesome, awesome secondary thing to try. And that brings up the idea of convection. When you warm something up, it becomes less dense. And when it becomes less dense, it wants to rise. And Maud is with us now. Oh yes, we're switching people at this other end of the table like crazy. Maud has come in. And Maud has a demonstration art using candy.
All right, so here I've just got 2 little round trays with Skittles in them. Alrighty, and here I've just got a little mug full of hot water. Just gonna pour it in there. And I'm gonna do 2 at a time. And you'll see what the Skittles are actually doing is that they're cooling the water so that that colder water will sink and will move towards the center. And the Skittles are like driving a flow of water into the middle.
I'm thinking if we could sneak a piece of white paper under there, it would be super awesome. We don't want to disturb it. Oh my gosh, look at those colors. That is awesome. So that's Skittles and hot water, and we're making this awesome pattern as the hot water drives this convective flow. Oh my gosh, look at that. I'm making an awesome pattern, and that is just so gorgeous. We're gonna let that do, and that was just, you saw exactly what Maud did. Skittles around the outside of the pan, hot water in it, and then the convection makes the magic happen. Awesome, awesome stuff. Oh my gosh, look at that one. That one's beautiful. That one is beautiful. And somebody's saying like, I love Skittles. Oh yeah, and actually I don't. But so this, to me, using Skittles to make artwork is a higher and better use than actually eating them. Thank you, Maud. Now we're over to Sheila, who's going to show us another convection demonstration we can do. If you get air warm, it rises. Sheila, take it away.
All right. I have a homemade hot air balloon out of a very thin plastic trash bag. You can see through it, it's so thin. And these are the supplies I use to make it. Just part of a 1 liter or 2 liter bottle, and you just cut a small segment to use on the balloon. And then I just divide the balloon up into 4s and put 4 pieces of tape around the ring and attach it to the plastic here. What I'm going to do, because hot air balloons need hot air, so I'm going to use a hair dryer and put it into the balloon. Whoop. Uh-oh.
Ground fault. There you go. Nope, I think.
Oops, I think I killed the hair
It's got
dryer.
a thermal cutout. Go ahead and turn it off and turn it back on again. Brandon, I'm gonna borrow the hair dryer from you.
Oh, thank
We're
you.
gonna hand this over to Sheila. No problem. We have a backup. And that's good. It was getting a little bit too hot and I had something to turn it off.
A
There you
lesson
go.
learned, don't let it touch the plastic.
There you go. There you go.
All right,
So this is something that you could do
it
with
is.
parental approval.
Yes,
Hot
you
air
do
inside
need
the
your,
balloon. And Sheila's gonna let that get nice and hot.
you want me to let it go right now?
Oh no, let it get a little hotter. I'm saying let it
Okay.
get nice and toasty. Nice and toasty.
Now?
And I think that sounds like a good choice. Go ahead and turn
Okay.
off the blow dryer and then we let it
Oops,
float away.
a little way.
And then it cools
Oh, look
and
at it
comes back
standing
down.
up
And there it's still
because of the
standing
heat.
up. This balloon is not ready to go back to ground yet.
It is not.
That
If
is
you
awesome.
want, oh, sorry, Brian. If you want to use this outside, you can also use a very thin black trash bag, and then that will get energy. It'll absorb the energy from the sun, so that'll make it more warm, and it'll rise up.
Awesome. And now over to Maud, who's going to do one last convection demonstration for us. And Maud has got a fish tank. I'll let her tell us what she's got going on in the tank.
Alrighty, so in this fish tank, I've got just a little bit of water to start me out, which is at room temperature, and I've got a little divider here in the middle, and I've got hot water in this pitcher that has been dyed red, ice left in it that is blue, and I'm just gonna pour them both in at the same time.
All right, so we got a cold blue side and I got a warm red side.
Alrighty. Just keep in mind what we talked about with the Skittles. I'm gonna take this out real gently, straight up.
Oh my gosh, and look what happens. The blue goes down below and the red goes up top. So instead of being side to side, now it's bottom to top. Bottom to top. Oh my gosh, look at that. That is amazing. That is amazing. And that was driven by the convection. That hot liquid wants to go up and the cool liquid wants to go down. Now for a closing demonstration, we got about 45 seconds left on the clock before 11:30. We want to be respectful of people's time. I got this pop can here. This is going to introduce to our next show. So inside here, there's a little bit of water and it's boiling and I can see steam coming out of here. And if I take this, it's got water vapor inside it. If I put it inside cold water, the water vapor turns into liquid water. That reduces the pressure inside the can and the can handily crushes. We took that can and we crushed it, and what actually crushed it was pressure. And that brings us to the subject of our next show. We'll be back in 2 weeks. Next week, we're taking a week off because we understand for Poudre School District, it's a teacher day. And so we're going to take a week off. We'll be back in 2 weeks. And that is going to be our biggest and best episode yet. We're going to do something amazing that we haven't done for years. Very much looking forward to it. We'll see you back in 2 weeks. Thank you for joining Little Shop of Physics Live. Thank you
Bye,
to
guys.
Sheila.
Bye, guys. It was
And to
great.
Maud.
Bye, everybody.
And to Brenna and Emma who are over there. We had quite the crew working on making Little Shop of Physics come live today. And thank you for all the people who took part. We'll see you in 2 weeks.